I don't forget, because John wants to be able to watch this later, so I will edit out all this stuff. But we'll wait just a few more minutes. 9 service members in the waiting room, and
I know we had like 34 sign up, right?
Yeah, we did. We had 34 people that were interested. All right.
But I know that this is really early, right? Because you military guys, you're used to not getting up until the afternoon, right?
Well, actually, you guys have the only 2 civilians on our staff with you right now.
Yeah.
Me and
you were, yeah, that's right. I remember that now. Yeah.
So.
But we have young children, so.
Not together.
No.
Oh, okay. There you go. I'm glad that you straightened that one out. Yeah, thanks.
Communication on Zoom is important, and anywhere. All right. Let's see. Wait just another minute.
You all set up, John?
Yeah.
You guys feel good?
So, yep.
We got a few more people joining.
I won't share my screen until we've
everybody
introduced ourselves and that kind of stuff. So,
great. All right, I'm gonna open the floodgates. All.
how you doing, guys? John Masucci here.
Still waiting for a few more people to join us, so we'll get started here in just a sec, ladies and gentlemen. Thank you. Good morning and welcome to another one of our Zoom meetings. The AP program has been working hard to find people that we can use and leverage their skills to help educate us and what we're doing and what you guys and gals are all doing and trying to do in your businesses. So thank you for joining us, taking the time. I'm not sure how long this will go. I think a lot of that will depend on the types of questions we have and how specific they get. So just to kind of set the baseline, the Johns that I'm going to introduce, if you're on the other engineering call that we had, you'll already know who they are. But they are going to break down a little bit more about CAD design. I don't know anything about it other than the very, very Wikipedia Google search. So if that's you, you're in a safe place with me. So I may ask some very elementary, stupid questions, but I want you to feel free to ask questions too. So they're going to explain a little bit about the Onshape, that software program, that link that I had sent you. We're going to kind of walk through that. They're going to talk about their knowledge and understanding of CAD, and they have a wealth of knowledge and some pretty intensive software programs. So John Masucci, John Fortunato, welcome. I will pass the microphone to you, sirs.
Okay, great. Can everybody hear me pretty well? Is that?
Yes.
Okay, good. And so I'm John Masucci, and I'm an engineer. Casey gave me a really nice introduction, and we've given one previous talk on the whole field of engineering and design and the nature of how you create new things. And so this is sort of a segue to that. We're going to be introducing CAD. And let me introduce also my partner, John Fortunato.
Hello.
And we've been working together for quite a long time. And thank you for the opportunity to give us, again, like an opportunity to share some of our skill sets. And who knows where it's going to go. So once again, this is CAD, computer-aided design, and it'll be an introduction to the overall design process, and along the way, if you have any questions, feel free to interrupt. So I'm going to start by, John and I are not pros at teaching CAD, so we're going to get better as we go along. So feedback, and if we're going too fast, hey, slow down. So let me share my screen, and okay, and hit share, and then I'll get this.
Okay, it looks like your screen is coming through, John.
Okay, great. And I'm going to make sure I have access to, okay. So let me backtrack a little bit and talk a little bit about, what do we mean by CAD design? So this is just, I don't know, I think I might have shown this presentation during our last talk, but I'm making a copper bathtub for my wife. We're doing the bathroom upstairs, and I used CAD to design the bathtub. I used some of the shaping. I made this 3-dimensional figure of myself to make sure I could fit in the bathtub. And then here, these are images of sort of getting the design right. And some of this is pretty sophisticated stuff, but we're going to start at the beginning. So don't worry if then I sort of made these full-scale drawings. That just kind of that ultimately led to the welding up of a frame using, so CAD can be, you could be a professional CAD guy, or you could use CAD on your own for your own personal purposes to kind of make stuff. It all depends on how much time you want to invest. This is an example of a drawing. Are you folks seeing this stuff
Yes.
pretty well? Okay. And so anyway, that's just an example of, getting into the nitty gritty, using CAD to augment the design process, and leading to sort of this elaborate weldment here that you have. Oh, and by the way, maybe in the future, if somebody needs to learn to weld, Mr. Meyer, Colonel Meyer, forgive me, indicated that at some point somebody might want to make it up here to the shop to do some training. So all this is on the table. So yeah, so an example of, I had an idea in mind, and using CAD to then, sort of make it happen. This is, the forming of the copper and getting my son involved. All right, so that's just one embodiment of CAD, if you will. And the other thing about CAD, right, is that once you use CAD, you can then make neat. I don't know if this animation is going to actually come through as well as it is on my screen, and I may have shown this before, right? But the other nice aspect of designing stuff on the computer is that you then have the potential to present it in different ways to convey understanding. If you're going to get right. So this is John Fortunato mentioned, hey, why don't you show just like, how you go from some hand sketches to, right? You don't necessarily have to start with CAD, right? You can sketch things out from your mind's eye, and then get into CAD and make it into something that might be producible. So these are just sketches where I'm conveying concepts, and then they ended up making their way into some formal CAD incarnations. So was that a decent enough introduction? Anybody have any questions?
Well, John Casey here. I think there's obviously you can use CAD to create just about anything, and it doesn't have to be. I mean, it can be a new invention. It can be a bathtub, something that's been done before, and it's kind of neat to be able to do that. And it doesn't necessarily have to be something that makes a lot of money, or be patentable, or whatever, just something that you get to create. Now there's other
Right.
skills that go beyond that, but yeah.
Yeah.
So talk a little bit about, if you're ready, if you're prepared, about this Onshape. It looks like you
Yeah.
have it pulled up.
Okay, so I imagine you see my screen here. And so there's this Onshape application, and I invite anyone who went through the trouble of signing up. It's a really neat application, and it's free. And
It's
John and I
cloud,
were-
it's cloud-based and it loads directly in the browser.
right, you
Right,
don't,
so
there's
all
no
you
really
have
no
to do is go
installation.
to onshape.com and sign up for a free account.
Right, so I'm kind of here in this, when you sign in, and then you kind of come to this page, and here's where I was planning on starting.
Mhm.
Does that make sense to everybody? We'll
Yeah, I
start
mean-
here.
Yeah, this is like you're logged in. This is the first page that you come to once you're logged in.
And those of you who, we could potentially go through the whole setup procedure. It's basically, you gotta, but the idea was to kind of start here and go through the CAD. Is anyone else on the call sort of at this point?
Yeah, did anyone else sign up for the free OnCAD account?
Yeah, type your response in the chat area.
Yeah, well, yeah, is there a raise hand or something like that? So yeah, okay, good. So there's at least a few people that already have access. And like John mentioned, it's you can sign up for a free account, and it's as easy as signing up for an email account. So this is the page that you'll access immediately after logging in, and then John, you can, I guess, continue with your presentation, right?
Yep. Let me
I see somebody mentioned something about they did Carlos mentioned that he did sign in, but he was not able to get to this page. We could troubleshoot that at the end of the call if you like.
Okay. All right, so we're here. So one of the first things that you want to do is, if you're looking to start a project, is you go over to this create bar here, and you have the option to either create a document or a folder. And so what we're going to do first is we're going to create a folder. Does everyone see where this is? You see, I've got this create. Now you guys, I'm using a professional version. You folks that are using the free version, it may just, it may say that your objects are public, right? So one of the neat features by having the professional version, which costs some bucks, is that, your files are private. But when you're learning, your public files are, it's not that big a deal. At some point, you might want to think about getting a paid subscription so that your stuff is not public. So anyway, let's go through the process of creating a folder, right? So we click that, and we'll call this Semper Fi. How about that, right? And then we'll create it. And so now I have a folder, right? Amongst some of these other folders that I have that I've used, during COVID, I worked with MIT to design a really interesting ventilator, and there's a couple other things that, anyway, so, all right, so this is Semper Fi folder, and then I can click on the Semper Fi folder, double click on that, and you'll see that there's no documents. And everybody kind of following along that can?
Yes.
Okay, great. And so the next thing to do is, from a very basic standpoint, right, is we're going to create, right? We're going to create a document. Okay, and we'll call that document components 1. And that'll bring you to this screen here. And I'll wait a couple of minutes till I get some feedback that those who are following along are there. And let me know if I'm going too slow or going too fast or whatever. I imagine, so what you'll see is, right, you'll see these bunch of 3D projections, these planes. Now, if you have a mouse handy, or whatever you'd normally use for the cursor, if you right click and then move the cursor, you'll notice that your sort of perspective, your viewing perspective changes. Okay, and then, right, you can click on, if you move over to the right, you can click on front and it'll automatically get you back to the front view. Then you can right click and kind of get to this top view and kind of give you a top view. And you'll see how useful this becomes. And then the other mouse features, if you have a some sort of what's the name of that like that dial on a mouse that might enable you to zoom, a wheel. If you have like a wheel function on your mouse, it allows you to do a zoom. And just you know, to manipulate what we're about to draw. So in CAD, right, you sort of start out with a sketch and you apply a sketch to a plane, because you generally are just in CAD, let's say from the beginning, right, you're drawing in 2 dimensions, at least initially. So what I'm going to do is I'm going to go over to the sketch function here. Can everyone see my cursor, right? I'm kind of circling around here, and I'm going to click on sketch, and you see that it's asking me for a sketch plane. So I'm going to click the front sketch plane. Okay, and you'll see what it does. I'll zoom out, is it puts a sketch plane on top of the front plane. And then I'm going to go over, I'm going to grab some geometry. I'm going to grab this rectangle here. I'm going to click on it. Okay. And I'm going to go to somewhere on my sketch plane, and I'm going to put a square. And so I'm wondering if so, you know, I mean, I've been doing this, you know, 15 years. It's, you know, to me, it's like second nature, but there's some clicking and stuff involved. And if anybody's having any trouble, let me know. But
Yeah, just go slowly, John. There's a few guys that are doing it on mobile, and I expect for the mobile browser there may be some subtle differences just to the GUI and the interactions, but it'll be the workflow will be similar.
okay. So
yeah, John, I don't know, maybe you were gonna mention it, right? But there's that idea that that once you're logged in, right at the top there on the right hand side next to your name, you've got the Learning Center and the App Store, right?
oh,
So,
yeah, I completely forgot about that.
right?
So yeah, yeah, we could go there right now. You know, by the way, so we're going to step through some, you know, some steps, but if you click on the Learning Center here, right, it'll bring you to this pretty elaborate Learning Center. I know my network connection seems to be slower than it was earlier this morning, but this is a pretty amazing spot, because you click on these, so for instance, these like self-paced courses, and there's everything under the sun that you might be interested in terms of learning how to. So if there's one thing that useful thing we can do on this call is to sort of point you to Onshape, and then the second most might be to point you to this Learning Center, and you click on this like Part Design Fundamental course, you know, and it has like this whole suite of videos that will walk you through the design process.
Discussing some of the individual part models and features in on it. Spend a lot of time
You
in
know,
Onshape. A closed different features by default.
so I'm
after you
kind of
accept the feature,
breezing through this video. It kind of goes through all the
next up,
different.
we'll take these basics and apply
It's
them
pretty
to
amazing.
individual-
Yeah, there's a lot of information there, and there's also instructor-led courses that are available as well. So if you're looking for some assistance, it's probably available within the Learning Center.
Yeah. And so if we could then jump back to where I am here. And using your mouse, I mean, to center, if you ever get kind of lost, you can always kind of click front, and that'll zoom everything to where you need to do. And then just remember that I guess I have a couple button mouse, but I guess it's just a simple right click that enables you to rotate, right? But if you get into this front, I kind of always like to look from a perspective standpoint. But okay, so we drew this square on the sketch. And so the first thing that you might want to do when you have this basic geometry is to add dimensions to it. So I click on this dimension icon. It looks kind of like a dimension, right? And then I'll select the line that I want to give a dimension to, and it'll pull out. So that's the dimension that I drew the square in. But I can, when it's highlighted like that, I can make it whatever dimension I'd like. So I'll just say I want to make this 3 inches, let's say. And then, while this is still highlighted, the dimension icon is still highlighted. I can click this guy and I can make this into, maybe we'll call it 3 by 5, right? And I can unhighlight the dimension box, and I can move this in the direction that I would like to move it, right? By picking different pieces. And I can add some dimensions to locate this cross section. So I could dimension to 0, this fixed point, which may ultimately be important at some point. John usually explains this much better than me. He was pretty good at it earlier this morning, but like I'm basically establishing the location of the cross section to a 0 point, so that if I was to come back into the sketch, which we'll see, I can change the dimensions and the shape will react in the way that I expect. Okay, so you notice how what was blue is now all black, and what that means is that my sketch is fully constrained. I have a fully constrained sketch, meaning all the dimensions are there, and the sketch kind of makes sense. So then I can click my green arrow and say that I'm done. And what I've done is I've added to my design tree over here to my left, is I've created this sketch, and it's called Sketch 1. I could right click it and I could rename it, and I could call it, sketch of part. Okay, and or part 1, whatever. But so okay, you've got now this sketch. Now here's like probably one of the most fundamental aspects of CAD is the ability now to take a sketch and to turn it into 3D. Okay, so when you mention CAD these days, there was a time where when you said CAD, that everything was still in 2D, two-dimensional, like architectural drafting. But today, when you say CAD, they generally mean 3 dimensions. So we select this extrude tool, okay, and then this other dialog box opens up, and further down the line, maybe we can get into all kinds of exotic surfacing and what all this stuff means. But fundamentally, we want to make a solid out of this cross section that we've created. And so I'm going to select the cross section because in this box it says, right, faces and sketch regions to extrude. So it's asking me for a region that I want to extrude. And so I select that region, and you'll see that it kind of is giving me a premonition of what it intends to do. And I can change that. I can flip the direction if I'd like. Okay. I can change the depth, right? I can go here. I can say that I'd like this to be maybe on the order of 5 inches, maybe, and you'll see I'll hit enter, and it'll update by extrusion. And it gives me a bunch of options, which I'm really not going to go into right now because they're not all that important in an introductory class. But for instance, right, I could select draft and I could give it, let's say if I was making a cast part and I needed to include draft on all my bodies so that they could be removed easily from the mold. Right, I could just an example of some of the options that they give you, but I'm not in this instance interested in including any draft. But okay, so I'm done. I made this simple part. I've extruded it, and it's in my document called Components 1, and here it is, and I can rotate around. Anybody have any questions? Have I lost anybody? Anybody want me to go back?
There's been a few questions and comments in the chat, and I'm taking care of responding to those.
Oh, that's awesome. I'm not sure why I don't see the.
You have to pick the chat button and it pops up and then it'll be shown on your screen. So you're probably better off just leaving it minimized.
Okay, great. That's good because I'm on this little tiny surface screen.
Yep.
Okay, so I've got this extrusion. All right, John Masucci, big deal. You drew a box and you extruded it. And that's great. Now, there's a whole suite of options you can then do with this solid, right? So just for instance, right, I could just click this fillet button and I can select these edges and it'll put a fillet on the edges. And that might be really important if I'm designing, I don't know, a cigar holder, and I want to put some fillets here. And eventually we're going to put like a cavity in this thing. But so there are, there's a bunch of options, which will at some point go through. And when you play around with it, you can play around with these different options and you'll see what they do. I just wanted to add some additional geometry. And then when I'm done, right, I'll just click, yeah. And so let me just point out, so in this design tree, you'll have a list of all the things that you've done, and you can always go back and change things, right? I can go back to this extrusion and I can click on it and it'll come up and I can always change. That's the beauty of one of the beauties of CAD is that I'm not constrained to what I've already done. It can, in an infinite amount of time, I can always go back and I can change things and change shapes. I can go back to this fillet radius and I can change the radius from 0.2 and I can make it, 0.7. And there you go. I can update my design. And let's maybe we want to add a hole, to this shape, if you will. So I go back to my sketch plane or my sketch function, and I'll select this surface that I intend to put my hole on. And I'll select this. So now I'm in the sketch selection mode. And John Fortunato probably knows the terms better than I do. But so I'm in this mode where, since I'm in a sketch mode, now this pull down bar has the options that I'm generally concerned with when drawing sketches. And I'm going to select this point and I'm going to try to locate it. I'm going to put this point somewhere. I'd like to put it in the center. The one thing I can do is, well, let me not, I'm going to try to just keep it simple here. So one thing I can do before I put the point down, let's say, is I can use some of the existing geometry to locate the point. So I'll click on this icon and it's called project. And what it'll do is it'll project these lines onto my sketch so that I could use them to reference the center. Hopefully that makes sense.
Yeah, another thing too, right, John? So you can project anything from within the, right? So you could project something that's on the bottom of your current block, even if you had another another piece of geometry. You could project that. You're basically just projecting some geometric edge or surface back to the sketch plane.
Yeah, and I'm going to turn these lines by highlighting them. I'm going to turn them into construction lines because they're going to be part. I'm sort of going to help myself to locate the center. I could potentially be complicating this concept a bit, so forgive me, but so I just projected some existing geometry, and then I right-clicked them and I turned them into construction lines so that when I extrude later on, when I extrude the hole, they don't end up becoming part of the geometry that I'm really concerned about. But now, so I want to put that point now in the center, and right, so there it is. And then what I wanted to do is make sure it was in the center, right? So what we're going to do is we're going to constrain it in a vertical sense, right? This guy, and the midpoint should just pop up, but no, it's not. Okay, so what I'm
I
gonna
think
do,
you have to put another point at
yeah, I was hoping to not have to do that, but okay. So I'm putting I selected, I'm going to put another point here, and I'm going to put it in the middle. So I'm highlighting this line and I'm putting a point there in the center. And that's now, if I show my constraints, this is telling me that this point here is in the center. And then I can constrain vertically this point to this point, and that'll put.
You probably wanted to go horizontal, John, because you're
Yeah. Hold
so
on.
just undo that. Yep.
Yeah. There's I hope there's a simpler way to do this, but anyway, so I'm putting 2 points. I'm putting 2 points on these construction lines, and I'm ensuring that I'm getting to the center. I probably should have just put the hole in without worrying about constraining it to the center, but maybe this is useful to just so I'm constraining. So now what I've actually done is I've geometrically constrained this point to the absolute center of this guy, and I maybe I'll be apologizing too much. There's probably an easier way to convey this. But anyway, so what I wanted to do was put this point and force it. So now the thing that I can point out is, because I've geometrically constrained this point to the center, if I go and change the dimensions of my object, if I go back to the original sketch here, right, and I change this dimension to something other than what it was. So if we can make it 2, let's say, right? And then I go back to you'll see that, okay, but you notice how that point stayed in the center. And so that's a very useful, so that's, like one of the most important things to convey about when you're designing in CAD is that you can set up these relationships that are core to your design.
Right.
And then you can go in and tweak the design.
Yeah.
Okay, so we started out wanting to put a hole in the center. So I'll click on this icon now. Okay, and you can see down here is it's asking for a sketch point to place the hole. Okay, so I'm going to select the point that I intended to put the hole there, and I'm going to select it. And there you go. It put this, it's expecting this kind of bolt or screw geometry, and I can change that. Right now, it's asking for a clearance hole. It could be a tapped hole. It could be a simple drilled hole, which I think only limits the, gives you the option for drill sizes. But we'll call it a simple clearance hole, and it's got this geometry, and so we'll sort of leave it at that. So I've created my part. I put a hole in there. I'm going to maybe bolt that together, And let's call this, so right now, right, I'm in this document called components, and I've created my part. I could rename this. Anybody have any ideas of how, we can just call this, bracket? Bracket 1, maybe, okay?
Yeah.
And then I can create another part. Maybe there's, for simplicity's sake, we'll create something cylindrical and we'll constrain it at some point, because we're going to make an assembly. Right now we're creating parts and they're ultimately going to end up in an assembly. So we'll go back to our sketch tool. Okay, and I'll select a different plane, let's say, and select this, and then I'll select my circle tool. I'm now in the sketch and I'll select this circle tool and I'm going to put a circle somewhere. Okay, and then I'm going to go over to my dimension tool here again, and I'm going to put my dimension here, and maybe I'm going to make this a 2-inch or maybe 3-inch diameter circle. And I'm going to click OK. And I'm going to extrude that puppy again. And I'm going to select my circle. And now I've got this cylindrical looking device. I can flip it. I can change the depth. Right, whatever I want to do. And then I can click OK. Now, if you notice, see, so my tree here, the left here, my design tree, it has all the different features that I've done. And at any point, I can go back and I can change things. But notice now I have 2 bodies. I named one bracket, but because this cylindrical disk is like a closed volume, it's a closed volume, the computer software, right, the CAD, I recognize it as a separate body. And I can click on this and I can rename it, and I can call that, I can call it disk, disk 1 maybe. Okay. And if I wanted to make this into one piece, let's say, or I can highlight the body. Let me hide the sketch. What I'd like to do is, okay, what I'm going to do is move the sketch into position where it's likely to intersect. We'll go back to the sketch, and I'm going to move this guy over a bit. And so that I'm and then I'm going to hit OK. And I'm going to just demonstrate a feature. I'm going to go back to the extrusion. I'm going to make it a little bit longer. Maybe make it like, I'm going to flip the direction, and I'm going to make it 1 inch long because I want it to intersect my geometry. Let's see, is it going to intersect yet? 1 inch. Maybe make it a little bit longer just to make sure. I'm going to make it 2 inches, let's say. Okay, so it's clearly that these 2 bodies are intersecting each other. Yeah, you could tell, see that in the hole, but they're 2 separate parts. I can click here. I can go to this Boolean feature here, and then I can choose a union, right? And so I can union these guys together, and now it's 1 part. See, now I went from 2 parts, and it's effectively 1 part. Just to conceptualize, what I could actually also do a subtraction, right, between those 2, and or maybe even better, like an intersection. And just to, so isn't that interesting? So it's kind of an interesting concept, this Boolean operations, where I can create a single part that's a function of two different parts. It ends up becoming really, really useful. And these things become quite familiar to you as you're using CAD. But I'm going to delete this feature, and you'll see I'll go right back to my two parts. And I'm going to turn this back to only 1/2 inch in width, because really what I want to jump to now is maybe getting to an assembly, because now I've got my two parts. I've got a disc, and I've got this other geometry, if you will. And so I'm in this part studio, and I could add other part studios, right? I could create this other part studio, and you'll see that it'll bring me to this blank page. And so there's Part Studio 2 and Part Studio 1, and there's assemblies, and then there's the components. One thing about Onshape is that it's very wide. You have like a lot of ways to think about how you want to structure your design. And that's a little bit of a more advanced concept. So I'll just throw that out there, that you've got these part studios, and we're going to get to an assembly. Then you've got this components that has a couple of parts in it. And then you've got this folder that could have a number of components. So, you know, and I don't intend to confuse anybody. I know that I would find it confusing unless I've, you know, but because I've been doing this for quite a while, I don't find it confusing anymore. But initially it's like, well, wait a minute, you know, I can have components in a folder. I can have multiple folders. I can have multiple parts in a part studio, and the most important is not to worry too much about that. It's just that Onshape has, in contrast to other designs, which make it much more rigid. Like I have assembly files and I have part files, and that's about it. In some ways, it makes life a little bit easier, but ultimately, in the end, as you get more and more sophisticated, because then you can do funky things like share parts and share features of parts and join them together. And I've got gears, you know, with tooth profiles that I want to borrow from, and it gets really interesting.
You'll find the method that works best for you.
Yes, thank you, John. You'll find the method that works best. So what I wanted to do is stick with, let me delete part. I don't want to let me delete this guy, because I want to just stick with the part studio that we're using, which are these two parts here, right? We're familiar with these. And I want to jump to this assembly, right? So you have parts, and you have assembly. And many times, let's say if somebody's designing something, it could be like a piece of artwork, you know, with some kinematics and movement, or it could be, but you'll want to put something together. Maybe it's just two parts and some bolts. And so the reason why I'm stepping back and I'm, you know, calling attention to parts and assembly is that that's sort of like a fundamental language to CAD. Is I've got an assembly and I've got parts. And basically the process is to insert your parts from the stuff that you've created. And by the way, when you're in Onshape, you never have to worry about saving anything. You never have to worry about, you know, like where the stuff is. It's just always there. It's always on the cloud. It's one of the most beautiful things about Onshape is that you never have to worry about, oh, did I lose it? Did I lose that incarnation, that configuration that existed like 3 days ago? Did I save it in the right place? It's just always there. It's a really wonderful feature of Onshape. But anyway, so getting back to the assembly, I'm going to insert the bracket, and I'm going to just click OK. And so now I have, you'll see I'm in this assembly, and I've got this bracket. I only have one of them, but maybe I want to insert, because I'm going to actually use the bracket twice in my assembly. And I'm going to put this guy here. Okay. So now I've got an assembly, and I can rename this, right? I can call it, we could call it machine one, we'll call it machine one, right? And you could see that the name updates here below. And I could, always go between my part studio, right, where I've generated my parts, to my machine one assembly. And so now what I want to do is I want to orient this other part so that it's sort of in sort of a mating relationship, because I'm gonna put that cylindrical piece in the center. And so what I'd like to do is mate. I'm gonna fasten. Actually, maybe before I do that, I'd like to show that these are not constrained. So I'm going to be adding some constraints to my assembly so that it goes together the way that I'd like. But before I add constraints, what I want to point out is that I can move these things any way I want, because they're not constrained, right? I can rotate this stuff, and I can make animations, because right now they're just sitting in space. They're not really constrained other than to the space. They're constrained to the space that we're working in. Okay, but I'd like to constrain this face, geometrically speaking, to be parallel or opposite this face. And to be honest, it takes a while to understand what all these constraints. There's a lot of really great videos. And when it's been a while, I tend to forget how each one really operates, but let's hope that I get it right. So I basically want to constrain this circle here, this guy, to this guy, right? And it kind of, so notice how it put it exactly where I wanted, but not quite oriented the way that I need it to be. So I click this arrow and it creates that mirror orientation that I was looking for. And, so that's a pretty, right? So now I've got this roughly in this, the way that I intentioned it to be. However, I need them separated. So I'll go back to this fastened constraint and I'll click this offset, and I'll see this blue arrow here. That blue arrow says Z. This blue, it's telling me that that's the Z direction, the X, Y, Z in my three-dimensional space. So I'll go over to Z and I'll put in some number like 3 inches, and I'll flip it so that let's see. 1 second. Oh, let me do it. I gotta put -3 there, right? That's the, and then I'll flip it again. Fasten, -3, and flip that, and then we should be good. Like I said, it definitely will take time to, when you work with constraints, to, in your mind's eye, it may seem, hey, all I want to do is arrange these parts, but getting the constraints to behave the way that you want them, it takes some playing around. They've done their best to kind of describe how these constraints work. So now that these parts are constrained to each other, if I click on the part and I try to move them, you'll notice that they move together, and that's because they're constrained. So if I click this arrow and I move them, you'll see that now they kind of move together. And if we were on site, and we were in some kind of classroom, which hopefully in the future, one day that might happen, or if you were here for a week or so and we were spending some time, I could, be looking over your shoulder and kind of helping you along the way. But so we're kind of doing our best here with the Zoom.
I would definitely suggest going to the Learning Center and doing the making a part, making an assembly, and then if there are some concepts or some things that are still eluding you, then we can probably schedule like some subsequent Zoom calls to go over questions or direct contact.
So here now I'm gonna remember, so we also made this disc, yeah. And so I'm gonna insert this disc into the assembly, okay? And I'm gonna just use one of them for the moment, right? And I'd like to put this disc, let's say, in the center here, in between these two. And so I'm gonna just kind of make it maybe make it simple for myself. And I think if I use this revolute, I think that gives me an offset. Does that give me an offset? Yeah. So I can select the center of this. I can select this circle, and I can select this circle. See, and it'll put it concentric with that circle, and then I can give it an offset of maybe 1.5 inches, and that should put it in the center there. Okay, and maybe there's a shaft that's going to go. Maybe that's oh, so now I'm in this assembly, but let's say, oh, I forgot to put a hole. I forgot to put a hole. I can click on this. I can like double click on this guy, and maybe right click. And I think there's an option to see this option, edit in context. So I can click this option.
I'm gonna call.
Don't worry if you don't follow it right away, but I can edit. So what I'm doing is I'm kind of editing this part in the context of my assembly. And I can throw a sketch, because now I know where my hole needs to be. I can throw a sketch on there, and then I can project this geometry from this other part. See how it puts a circle there right where I need it to do, and then I can actually, right, I can put a hole there, and I can remove, and I can click OK. I'm going really fast. Don't worry if it's, and then I can go back to my assembly, and then you'll see, like, so it ends up being a really powerful feature. While I'm in an assembly, I can locate other geometry that's pretty important to what I'm trying to achieve with my assembly. Okay, so, I've got this pretty simple assembly. I might want to add a couple of fillets. One thing I'll point out is I can still move this assembly all over the place. That's interesting. Oh, because I'm back to the assembly. Oh, there was just too much of a delay. Okay, so the point that I was just trying to show is that this assembly is not yet really anchored to anything. The other one option that you have, and it's not the most important thing to show at this moment, but there may come a time when you need to fix a part so that it's constrained to ground, if you will, right? Effectively, as if it's constrained to earth. And if you notice, I selected, and it puts this ground feature next to this part. And now I can't translate this part anymore. No matter what I do, if I try to rotate this part, it doesn't move anywhere. But if I was to remove the fixed constraint, if I click unfix and I clicked on it, you'll notice that I can rotate, I begin to rotate this thing. Just a point of, now we're going to get into, well, okay, now that, okay, John, you've showed me how to make a couple of parts and put them in assembly, big deal. I'm going to learn this in a couple of hours. So now what we're going to do is we're going to go into the drawing piece. So what John and I are trying to just kind of give like an overview. Here's your software application. You have something in your mind, you might sketch it. You start off with trying to create the geometry, then you kind of put it together and you constrain it if you want. You don't have to use constraints, you can just kind of position it. But the constraints, as the assembly gets more and more complex, it becomes more and more useful. But then you have to make drawings, because you know what? you're going to send these parts to a machine shop, or you're going to be machining these parts in your garage. And so the next step is to go down to this bottom bar here, if you will, and click the plus sign, and then create drawing. There you go, right? You're going to create a drawing, and so there's a whole bunch of drawing standards, ANSI, ISO, sizes, A, B, C. The A is typically the smallest standard size drawing you can make. So we'll just stick with that for now, but you can play with that. And they have all different kinds of drawing templates, but let's just stick with the ANSI A. And so it's loading the drawing template, and here we are. Okay, so it's got a title block already settled, and it's asking, okay, well, what parts do you want to draw? So initially what we're going to do is we're going to click our bracket, right? And we're going to put a view here, and it's going to create that view, and then it's going to allow me to create another projection view, which is the side view, right? And okay, and I might want to, then what I could do is move these views down a bit, because I'd like to then create this other. So I'm selecting this projected view option, and I'm going to highlight this view, and I'm going to pull it up here, and it's going to give me like the top view that I'm looking for, because I'm going to need to call out that geometry in order to make the part. Does that make sense to everybody? Am I going too fast? Do we want to take a break to catch up? Any questions?
John, great. This has been great. I think I see all these questions and links, and people are engaging with John F on the chat side.
Yeah, it's great it's great that the two of us it's so very fortunate for me, because I don't think there would be I wouldn't be able to respond to the text and keep my thought process going. So it's great that I've got John Fortunato here, that we're working together on this. This is working out much better than
well, and so just to take maybe a 30-second break, what I was thinking about while you're going through this and watching you design the box and the wheel and I mean, it's just, I've never seen anything like that. But you think about everything you use every single day, from a flower pot. Somebody had to think about what was that, how high did it need to go, how deep, what was it made of, and all of those things you can get into at another time. But the one thing I was thinking about, and this is just to give us a mental break and say something cool about you, is if you don't know, John Masucci's everyday car is a 1931 Model A?
Yeah, Model A Ford, yeah.
Model A Ford, suicide doors, beautiful car. I was, after you sent me the picture, I said, I got to have one, but I don't make that kind of money. So I can't fix, and I don't know nothing about cars and fixing it up. It's just a cool car. And to think about, like, they made that vehicle was made without technology like this.
Yeah, it's a great point.
All by hand. Yeah.
All by hand.
Hand drawings, hand CAD, slide rules, right?
No calculators, no computers, no CNC. So that's a really great point, Casey. And it's also a testament to American ingenuity, that whole Yankee ingenuity piece that, from the Revolutionary War on up. It's something to be very, very proud of. And it's something that I myself am very, very proud of. This country has given me the opportunity, to work with my hands. And Casey, that's a really excellent point. Like sometimes it could be, CAD can be, this complex thing. It can be very helpful, but don't let it stop you from sketching your ideas on a piece of paper with a pencil. That's a really great point, Casey, that you're making. In other words, I find that there's lots of people that are gifted in these ways, and that all they have to do is start drawing. and all of a sudden and they find out that they're talented in this, and you can go from, you could just draw, and maybe that's freehand drawing is another class in the future, like maybe it's so sometimes CAD can trigger, well, wait a minute, before I even get to CAD, freehand drawing, I can capture sort of like what I was showing in the beginning. I can start drawing these things. And maybe that as a class for the future is like, how do you begin to draw freehand in 3 dimensions? If you notice, is this a worthwhile thought, Casey, for you to spend some time on?
Yeah, I actually think that, I mean, even before getting to this stage of CAD, you see something in your mind that you think would be a useful tool or piece of equipment in the marketplace, but you have to find a way to get it outside of here and onto something physical. And then maybe from there, the next step would be, let me talk to somebody that works in the lawn mowing business. This would be something that you could use. And if I was to create it and come up with a prototype, and there's stages to the development process, and you guys as inventors go through that all the time. But this has been really cool because this is a stage that I think takes us from the idea and this floating thing to shrinking it into something semi-tangible that can then be produced in a manufacturing plant. Yeah.
Just continuing along that thought process. So when I was working for Sloan Kettering doing some medical instrumentation design, and I had in my head these different concepts, I said to myself, there's no way that I could sit down and, I had to convey these concepts to my customer. And I had to make a choice. I'm a busy guy. I could sit down and I could do this on CAD, and I would eventually have to do it in CAD, but they would have to make it, let's say there was this design concept and there was this design concept, how this thing was going to be attached. And I could invest all the time to put it into CAD twice, or I could sit down for an hour and just sketch it out and convey the concepts. And so the point that I'm making is that even in the world of digital, right, but just being able to, it can be very efficient to just do it the old-fashioned way. Sometimes when you're prototyping something, instead of having to draw all of it, you'll draw only some of it, and then you'll just quickly go into the shop and weld it together because it's just quicker that way. There are some perils with that because, when you're thinking about it and you're drawing, you're actually helping yourself so that when you're actually welding things together, you're not going to weld something and then find out that it's in the wrong spot, because the changes that tend to need to be made as a result of errors when you've got physical components end up being much more costly than having to erase a line and redraw it, right? So again, from the Model A Ford and American ingenuity and just my uncles were involved in World War II and also World War One. My great uncles, other family members, and they used to always say to me when they would be working with me underneath the cars or whatever it is that hey, we won. The American Jeep had like 4 or 5 bolt sizes, as opposed to the German Jeep in World War II that had like 25 bolt sizes. They used to always say, like, we won the war because the way the American engineers worked was that keep it simple, keep it simple, stupid. And it's you see that in a lot of American stuff. Is it tends to be robust. It tends to be less complex than some of the stuff coming from over the pond or from Asia. I take a lot of pride. I take a lot of pride in sort of that Yankee American ingenuity kind of piece. So thank you for giving me an opportunity.
Yeah, well, John, what's that adage or whatever of it's not it's how much you can take out of it and have it still work, or you know what I'm talking about?
Well, Einstein said, make it simple, but no simpler, right? That's not quite what you're trying to say, but
yeah.
Okay, so so that was a nice, interesting opportunity to kind of get into some of the design philosophy, you know.
So sorry to interrupt. We are about a little over an hour in. I know that at one point we had discussed going an hour and a half to 2 hours with this. So I want to just check in on the time, make sure you know where we're at, and leave some time at the end if anybody had any questions. So
Yeah, my
continue
plan
on.
is to, my plan, Casey, did I interrupt you? Forgive me, finish.
No, sir.
Okay, yeah, my plan for those, I was gonna just now show like how to add some dimensions to this thing and then open it up to questions.
Yep.
We're actually pretty close to the end here. So the
Right, and the
Mhm.
value here in making the drawing, right, of course, and the adding the dimensions is for documentation for yourself or for handing it to somebody to machine it for you or to share the design intent. Right, I mean, if you're making something that's custom handmade every single time, then maybe you're just using this as a reference.
So while John was, talking, I'm just, adding dimensions to my drawing here by just clicking on this dimension tool and highlighting the geometry that I'm looking to. And so a machinist would look at this and say, yeah, okay, I got it. I may, go down to my title bar here and see it tells me to add the material, right? So I would, click on, well, I would get out of the dimensioning tool and I'd click on this and it'd give me the opportunity to put in, a type of steel, maybe it's, 40, 41, 40, chrome moly steel. And that would tell the machinist, right? And then I would tell him the kind of finish that I wanted on there. And maybe this would tell him the kind of tolerances that I expected. A lot of this gets a little bit more sophisticated than what I'm intending to do here in an introductory class. But, we would give this a title block, I don't know, this is the, walking. Usually it's all in caps. Oh, we call this, right, this is just a component, so this is not an assembly, so we'll just call it,
Whole block,
what's that?
whole block, block with hole or something like that.
I don't know why I got stuck on the.
Yeah, just kind of just hit it square in the jaw with that one, right?
All right, so anyway, we've got the drawing named, we've got some dimensions on there.
John, I would just mention, right? I mean, it's probably getting into the minutia, right? But like you would set like your dimensions based on like the necessity, right? So 2.000 might not really be what this block needs. You may only need 2 decimal places or 1 decimal place, because the more zeros you add, the more expensive it's going to be to manufacture.
Right, so I might want to just call this out as with just 1 decimal point, right? And just say, because so now this is 6.0 and you go down to your tolerances here and it says that anything, that just has, 2 numbers, and then you could add your tolerances to it. Gets right, it getting a little bit into the minutia, I think. That's like another class on tolerancing. We could spend 2 weeks talking about tolerancing. But
yeah, and you were gonna touch base also on, which I think it doesn't even make sense to now, but like geometric tolerancing, that would be a whole other class too, right? So
yeah. See, and I can change my view properties, and I can say right now it's not showing any kind of hidden lines, but I'd like for it to show the hidden lines in a And I'm wondering, maybe I picked the wrong selection box. It should be.
That should be it.
I'm surprised that I forgot where.
View simplification might be it, right?
No, it's not. They may have changed it. Give me 1 second, guys. I'll figure this out in a second. Let me open this up. And this is the right top. This view, right click, properties. And I should be able to show all the hidden lines, and it's not. Let me just try one more time. Oh, here we go. New properties, show hide sketches. That's really weird. It was for the longest time in here. Orientation, best performance, tangent edges, solid, phantom, sheet. Huh, interesting. So I'll have to dig that up. But typically, you would want to show the whole geometry here, and it's gonna really bother me that that I can't just.
I'm looking. I'm trying to. I'm looking into help to see if I can find it for you, John.
Yeah. This.
Oh, modifying views. Oh, here it is. Modifying views through the right mouse button. So you might want to right mouse button on that and then do show hide hidden lines.
Yeah. Tangent edges, hide threads, view properties. Right.
Oh.
It's not.
Oh, maybe you have to select the. There you go. Oh, it's not letting you. Okay. Well, we'll figure it out at some point.
It's really, it's one of those things that it's probably as soon as I get off, as soon as
you'll find it.
I'll find it as soon as I. It's interesting, but okay. So that pretty much what. Show hidden lines. There it is. Okay, that's what I was trying to show. Is so.
Hey, how did you get it?
Yeah, it's very subtle. You don't actually click it. You just highlight the box. Don't actually click it, and then right click, and then there's the option to hide and show hidden lines.
Yes.
But the thing that I wanted to show is that typically in these drawings, you want to show the hidden lines because it gives the machinist, more of an idea of, right. And then you would, so this is the drawing one, and then you would create another drawing. Now, the other thing you could also do is, right, you could create this assembly drawing, right? You could create a drawing. We'll call it an A, and then I'm done. We're going to open up for questions. It's been a while. You guys have been hearing me talk for over an hour, so. But I just want to quickly show that you don't just have to show parts, right? You could go to assembly, right? And one of these things, you can go to assemblies up here, and you could click on the assembly, and you could throw the assembly in here. And create an isometric flow. We'll just leave it like that. Right, and then so this enabled me to get out of this, and then I can get rid of this view, let's say, and hopefully it won't delete the other view, and I could come here, I can move this into the center, and I could highlight this view, and I could change the view properties, and I could scale it. Right now, the scale is 1 to 5, but maybe I could make it 1 to 2 or 3. And it should be a lot bigger. Change the scale, and then if I wanted to convey, I could have this assembly drawing. Okay, so anyway, that'll conclude the introduction to CAD on Onshape. Hopefully that was interesting and helpful. We'll get better at this as time goes on. And any questions? Anything that we can? Anything particularly triggered your interest, maybe for the future?
Yeah, this has been good. I asked last time, we didn't have as much time at the end, but now we've got plenty of time to, if anybody has a project they're working on, an idea that they want to share or maybe talk about, let us know, and we can unmute you. You can ask some questions, or any struggles you may have with this sort of software programming, or if you have questions about what you learned today, now is your opportunity. And in addition to that, no pressure now if you don't want to talk now, but we can connect you with the Johns at a later date. We've already had a couple of service members in the program get connected with them, ask questions about some inventions, some things they're working on. And these two guys are more than willing to help and give away their time. So yeah, I'm kind of opening it up. If you want to type it in, that's great. If you want to be unmuted, I see Bob. I'm not sure Bob, if you've unmuted yourself, if you want to ask a question, fire away.
Yeah, I'd love an opportunity to actually, if one of you guys wouldn't mind, unmuting, just like, we'd love to have hear an actual question. Would be great.
Yeah, John, I've got a question.
Oh,
this is Bob.
Hey, Bob.
Man, this is really incredible, and it seems pretty robust. I just got on it just with this call, and you described some really cool things, like essentially, okay, take some time to draw up your idea, and then obviously we can put it into this software. That's a part of the workflow, but what would be like continuing on with it? Would this be able to, for example, be put into a CNC router file or something? Or can you kind of share what would that workflow might be for?
Yeah, that's a great question, Bob. We didn't even think about that. And that's why it's like really important. I appreciate the engagement, because we can't possibly think of everything, but that's a great question. Like, okay, so the other way that you can, and some might say even like, so relatively recently, so what you can do is, so you've created this geometry. So one way to get people to understand your design is to send them drawings. And in some cases, that's like the simplest way to do it, right? But if they're sophisticated enough and you have access to CNC or 3D printers, right? You can email. So what you can do is you can go back to your, let's say, go back to your part studio, and right, your parts will come up. And again, I'm working from a small screen, so I'm gonna just get this out of the way here. Okay, so now we're back to our parts. So what you can do is you can export these parts. So let's say
in the format that you can pull into the 3D printer.
Right. So see, I've highlighted my disk part. Let's say I wanted to send this part just as it is, as a solid part, right? I could export this part, and you see it comes up, and I can choose the format. Now, most people, they like parasolids, they like I just follows, like if you're making like a 3D printed, a lot of them times they like the STL file format, but you could consult the person who's going to be doing the machining for you. A lot of times that's the step file format, right? And then you click OK, and it's going to download that part, and you could see how it's downloaded the part for me. And I can open this up in a separate viewer because it's a step file, right? So
Now,
I can
John,
open
one
up-
thing that you wanted to, that you were gonna mention, right, was also besides the learning center, right, was also that app store, right, which
Yeah.
opens up probably a lot of horizons for additional apps, whether it be CAM or
Yeah.
analysis, right?
Yeah, that's great. Bob, so your question is triggering a lot of stuff that John and I had talked about, but got
Forgot,
lost in the
yeah.
presentation. There's this other piece called the App Store, where you can take the geometry that you've created, right, and you can create computer-aided machining. So there's these apps, and some of them are free, not all of them, depending on which one you pick, but that will work with Onshape to then, let's say you purchased like a little mini 3D printer, or you purchased a little CNC machine. It would take your geometry and then create the machining program, right? All the commands to then machine the part out of a piece of material. So the other point that in this app store is all the other applications that work with Onshape to help facilitate what you're intending to do with this design that you're working on. Some people, like bigger companies, it's important to like manage all the data. We won't get into that. Some people need better simulation. So, maybe you'll have a question. You could spend, 8 years in engineering school and learning all things about strain and stress and being able to calculate all this stuff, which John and I have done. But today, if you're worried about if something is going to break, you can take your models and put them in this simulation software, and it'll tell you you'll have to figure out how to apply certain loads, which, John and I, at some point, this could be another class, how to take the parts that you've designed and then apply loads and see if it's going to break. And then you can redesign your part so that it's a little bit stronger in the areas that are showing where it's weaker. Yeah, so that's like, it's this enormous space. The other piece, Bob, that's connected to your question is, and John and I were talking about this just before this call. So there's CAD. And if you notice, CAD is kind of rigid, right? It's kind of very, in the sense that, it's dimensions and accuracy, and then there's, everything is sort of orthogonal, perpendicular lines and mating parts and constraints. There's this really kind of, and it's all good because it's intended, you could, on Onshape, you could design an attack helicopter if you wanted to. You could actually make the whole helicopter using Onshape, right? There's this other aspect of CAD, which is like maybe more free flowing, and maybe it's really kind of surfaces and animations. If you've noticed some of the computer graphics and like simulation based stuff, which is maybe the topic of another class down the road, where it's less about machining and creating parts from planes and lines and extrusions, and really about starting with blobs and morphing blobs into stuff, and then using these blobs and having intelligent software turn them into shapes that you intend, and then animating them. So I'm just throwing that out there. Like there's this whole other aspect that we're not even getting into, which is sort of more on the artistic side, right? So CAD is really kind of more technical engineering. I'm going to make a bicycle wheel that has to work the first time out. And then there's the other person who's like, no. My bicycle wheel is really part of some artistic expression that I want to, and they're both great, right? But they're kind of two different parts of your mind, right? The one's sort of the technical side. The other one is more on the artistic side. And I have experience in that. It's not really the center of my bell curve, but John and I could also demonstrate some of that stuff too. Great question, Bob. I kind of took it off into space somewhere, but
oh, but it's perfect. I totally appreciate it. And especially how you just touched on the creative part, because I guess with me, I've been working on surfboards, so carving out a hollow surfboard. I don't know,
Wow.
is this showing up?
Yeah, that's really awesome stuff.
And so fuck foam, I'm working with wood. I love the feel of it. And so I've had a chance to scan shapes that I really like, and just classic shapes of surfboards. But this part, these ribs, is what gives it the rocker. And that's the part that would, benefit from having some kind of CNC and design to it. And then the rest is all, art, it's by hand, and it's kind of like, it's sharing a bit about the vein that kind of where it applies to me, what we're working on here. But this is really good stuff. And I appreciate both the art and the engineering side, but
yeah, no, that's really great. No, that you're pretty far along now. Surfboards are, there's like this internal, right? There's this structural component, box sections and rigidity, and then there's the whole fluid dynamics and understanding how you want to cut through the water in the most efficient way, and the contours and the beauty, the aesthetic of it. It's a great, like maybe in another life, like I'm planning, maybe one day in heaven, possibly, that I'll have infinite amount of time, to spend with people I couldn't have spent time with, like like in another life, I could probably spend my whole life designing surfboards. It's like, it's such a great endeavor. And I see that you've got pictures there of structure, and you're working with natural materials. So that's great. Yeah, that's great. Are you using like epoxy to glue some of the section stuff?
It's mostly wood glue, and then to finish it, it's using there's no epoxy in it really at all. It's just using natural wood. It's a Polonia is a wood that it's got a very natural kind of porousness and buoyancy to it. And so I'm really just trying to use as least amount of stuff as possible, as far as just wood glue and wood. And I've just been experimenting, but it's the design. It seems like it could really benefit with the hollow board is using some plywood, the ocean plywood or marine plywood, and being able to CNC that rib system out, because it's kind of a pain in the ass to just do it all by hand. And this is wonderful. Absolutely. I really appreciate it.
And I could help you. I'd be more than happy to kind of like help you however I can to kind of, I've got like a lot of experience with, turning handmade geometry into something that could then be CNC machined. And then the other piece is that, if you ever wanted to kind of like separate your design from others, is optimizing those pieces from, like we were just showing, from like a stress standpoint, right? Like how thin can you actually make it so that it's a lot lighter, let's say, but still be strong enough and not have to have had actually had to break a dozen of them to figure out that it was too small. You know what I mean?
Well, I've learned a lot already. I'm sure there's a lot of other questions, but I would definitely appreciate that.
John, is your ceiling leaking?
No, I don't know. The fan was going crazy, so I don't know. I had to turn it off. But I know Carlos mentioned that he was having some problems getting onto Onshape, and I thought so. Like at the point where we're wrapping up the call, or if there are no other questions, maybe he wants to share his screen, and maybe we could help him troubleshoot what's going on. Why he's having a hard time logging in. But does anybody else have any other questions or comments?
Again, if there is nothing that you want to share now or something comes up later, just get in touch with me or your advisor, and we can get you connected to the Johns, and you guys can set up a good time to chat. So
yeah,
this has been great, guys. Thank you again for I got a little bit of an education. I'm still dumb as a rock when it comes to this, but I appreciate it. I like to see and learn something new. And Bob, thank you for sharing what you're doing. Now I know who you are. I've seen your face, and I knew you're the surfboard guy. So that's really cool to see that kind of come into life and how you're going about it. And it's very clear you're passionate about it, which is a completely different Zoom call that we could do. It's got to start somewhere from passion, because you will hit roadblocks. But yeah, I think that's it for today. If there is anything that y'all need, I think I'm the only advisor left on the call, because we had a couple of things pop up with our other advisors to jump off. So if anybody needs anything, please reach out. And Johns, I'll let you guys close it out.
All right, terrific. Thanks, guys. Thanks for giving us an opportunity to share some of this knowledge. And of course, always goes without saying, some of the most important stuff goes without saying, thank you for your service and all that. One thing you'll notice about John and I is, yeah, we're engineers, but we're also very, very passionate about this stuff. And so you guys are giving us an opportunity to take some of this formal knowledge and help project it. And we'll get better at it over the time. We don't do this every day. So we're learning as just as much as we're teaching. Thanks again.
Fantastic. All right, guys. Thank you
Take
very
care.
much. Have a great day.
All right.
Yeah,
Bye-bye.
yeah, Casey, before you close off, I don't know if Carlos, if you want to try to troubleshoot that thing now, or if you want to try to try to sign up again. I haven't. He says he's still there. Okay.
And
Okay.
yeah, if you wanted to just reach out to us independently, we can walk you through signing up on Shape.
That's probably gonna be the best way to do it.
Okay.
Carlos, I will connect you with the Johns, and if they've got a few minutes now, I'll just shoot an email over, and you guys can get it worked out.
Terrific.
And we'll go from there.
Take care, guys.
Perfect. Thank you, guys.
Great. Thanks.
Have a great day.